everyone. Good afternoon and welcome to today's session. We are going to talk about cloud on-ramp for SaaS for next 1 hour. Before we get into the agenda, a quick introduction about me. I'm Sai. I work as a technical marketing engineer in our SD-WAN business group, where I focus more around cloud networking, analytics, and so on. When I'm not working, my hobby is to do hiking. And when I'm doing hiking, I use a fitness tracker in order to monitor various things like the step count, other metrics, and so on. And that helps me keep track of my hobby and how I'm performing when I'm doing hiking. Right? On the very similar lines, Cloud On-Ramp for SaaS can help you monitor the SaaS applications on your SD-WAN fabric, track the performance of the SaaS applications, and help you optimize them, right? So that's the whole goal and the problem that we are trying to solve with the Cloud On-Ramp for SaaS. So in today's session, we are going to see how we do that using Cloud On-Ramp for SaaS solution. So before we further get into the session and the agenda details, a quick housekeeping rules. So there is a WebEx space that is created for this specific session. So you can join this through the Cisco Events app. So, and this space is going to be active until like Feb 28th, but I'll be more than happy to keep it active longer as well in case if there are questions coming in or if you'd like to discuss something more on the session content or anything in general in the SD-WAN as well, I'll be more than happy to help answer your questions. And in the same WebEx space, I've also posted the Slido link, which I'll be using for some of the Slido poll questions coming up in the presentation later as well. So now let's look at what's today's agenda. We're going to start off with why do we need SaaS optimization? I mean, what is the problem that we are really solving by using SaaS optimization or Cloud On-Ramp for SaaS, right? And then we're going to go into overview of how the solution works. And there are certain special integrations that we have done with certain SaaS applications like Microsoft 365, which is the most common SaaS application that we've seen out there that is highly adopted. And we have some special integrations done with Microsoft 365, so we're going to cover on that. And what we have seen also over the growing in past is customers were looking to do similar kind of optimization for their own enterprise applications that are running either within your own data centers or running in the public cloud hosted within your cloud hosted accounts. Right? How could we do similar kind of Cloud On-Ramp for SaaS optimization for those applications as well? And then we're going to look at how the SaaS optimization could work together with the security in place, because now SSE or SASE is new trend that's going on where you're all looking at adopting Cisco Secure Access, Zscaler, or other kind of cloud security solutions, right? So we're going to look at how these two things can interop together and then cover some of the deployment scenarios as well, and then wrap it up the session after that. So now let's look at why do we need SaaS optimization. So what are we solving, right? Before we get to why, just to lay a picture, this is the typical SD-WAN fabric that you'd see, like a branch location could have 1 or 2 or 3 circuits in certain scenarios, where a couple of them could be a direct internet access circuits or public internet circuits, or one could be a private or MPLS link, which is used to connect to other data center locations and egress from that data center location. Now, in this kind of network, what are the challenges that we have with the SaaS application, right? When you start using SaaS application, the very first question that could come into your mind is, which path should we use at any given point of time? Is it the internet path that is performing the better at this point of time? Should we use it? Or should we backhaul the traffic over a data center and egress from there because there is an outage or there is slowness that is being detected on the local internet circuits? How do we continuously monitor this kind of performance on all those paths? And in case if we notice certain things, how do we also do a failover from one path to the other path in order to restore the performance? These are all some of the problem statements that comes into mind to us, like when we think about SaaS optimization. I would also like to hear from you quickly as part of the Slido poll as well to see what are some of the problems that you see as part of the SaaS optimization as well for us to understand from your perspective. So here is a quick Slido poll. Okay, let's start. Sorry for the glitch. So on all your WebEx app, there would be the Slido link that I pasted just 10 minutes ago before starting the presentation. So if you could all open your app and then see the last message in that space, there would be a link you will be able to click. Shortly, I will also be opening up the QR code, which you can also scan and then answer my questions, the Slido questions from there on. Okay. Right. You could scan this QR code, and the idea behind this question is I wanted to know what are some of the common SaaS applications that you are using in your network. And then based on that, I want to tailor the presentation as well to, depending on that, focus on Microsoft 365 more, or should we talk more about WebEx, or should we talk more about the custom enterprise apps, or what do we focus more on? Yeah, I see some responses coming in. Thank you. Thank you so much for those. Give a few more seconds. I think clearly, whenever I run this poll from last 2-3 years or so on, when I've been working on this product, always the Microsoft 365 is the one that wins this race, where that's the most commonly used application. And that's the reason as well why we focused on special integrations with that, which we will look later part of the agenda to see as part of the session as well, to see what further we can do better when it comes to Microsoft 365 and how can we guarantee a better experience for M365 users in your SD-WAN network or SD-WAN branch locations. Okay, I see a good number of responses. Thanks again for that. Let me go to the next question. So the next question is, I was mentioning earlier from our perspective, what are some of the challenges that we see when we talk about SaaS applications or accessing SaaS applications as part of SD-WAN fabric, right? So we wanted to hear from you to see what does come top of your mind when you think about SaaS applications optimization within your SD-WAN fabric. And the main reason why I'm asking this question is, again, also, if some of these challenges is something that we already address or have been some things that we have recently developed or introduced as part of the cloud on-ramp for SaaS, I will be touching upon them as well throughout this presentation. And if there is something that we haven't addressed so far, this will also help us a lot to take this as a feedback and innovate further within this cloud on-ramp for SaaS space. Thanks. I see some questions coming up. I think the path selection, latency, security is one of the concern. Cool. I think that's where we're definitely going to touch on how SSE and cloud on-ramp for SaaS together would work together, or what happens in those kind of deployment scenarios when you are using SSE in mix to access the SaaS applications. Identification is one thing that I see. In DPI, not detecting the applications. So that's where there are certain enhancements done, again, using our NBAR SDAVC classification as well. So I'm going to touch on some of them as well to see how we can classify the applications effectively using those techniques and give the first packet match benefit or first packet match classification for the SaaS applications. Again, thank you so much for all these inputs. This helps a lot. I'll probably leave the poll also on for a couple of minutes more, probably till the end of the session as well, so that you could, if there are any other responses or feedback that you'd like to add, feel free to add it here. That being said, let me go back to the slides again. So now let's look at the overview of cloud on-ramp for SaaS. There are 3 main steps when it comes to cloud on-ramp for SaaS. The first one is when user is accessing SaaS applications, or when we talk about SaaS applications, right? The first thing that comes to mind, or the first packet that we would see in the traffic flow, is a DNS request. So what do we do from the DNS request standpoint of view? So in the very introductory slide, I showed there are different possible paths for SaaS applications from a given SD-WAN branch location, right? Across all of those possible paths, we first try to resolve a probe endpoint, which we can probe for different SaaS applications. Depending on the type of application, there is a specific probe endpoint that we use in order to measure a probe, in order to probe and then measure the path metrics such as loss and latency and use it for our best path selection. So once we do that DNS resolution and get the IP address of an endpoint that we can probe, then essentially, again, across all these possible paths, we periodically send HTTP or HTTPS ping, depending on the endpoint type that we are probing, and then periodically keep track of what is loss or what is latency or how much latency that we are seeing on those paths that are available for the SaaS applications. And then use all of these metrics like latency score and loss score and come up with a composite quality of experience score for application on each of these paths. This is what is going to be an indication for us to say how the application is going to perform when it selects a particular path. And then obviously, then the path selection thereon would be selecting the best performing path among all the possible paths that are available for the SaaS application at that point of time. So now we saw this overall overflow, and now we'll go into each of these steps as well in detail. The first step, which is the DNS packets, we earlier talked about the resolving DNS for the probe endpoint and then getting an IP address and probing. And now when the user traffic starts flowing, like for example, imagine user now tries to join to a Teams meeting, or they try to download a file from SharePoint. Again, the very first packet that would be generated by the user mission is a DNS request that would be hitting our SD-WAN router, which is in that particular location, acting as the gateway for that user traffic. And now the SD-WAN edge router, using its application classification intelligence, it would identify, okay, this belongs to a SaaS application for which Cloud On-Ramp for SaaS has been configured for, and it intercepts that particular DNS packet, and then it will now override, no matter what DNS server that user could have been using, we override with the DNS server that is configured as part of the transport VPN configuration of the SD-WAN router, and then send it via the best performing path at that point of time for the SaaS application. So you might be wondering, why do we do this, right? We do this in order to do two things. The first, the user, there's no guarantee what DNS server that user laptop or user desktop would have been configured to use for, and there is no guarantee it would be optimally resolved to the closest SaaS servers or SaaS application endpoints that are closest to that particular location, right? And now, when we override that by using the same DNS server that was used also earlier for probes, that will ensure we would optimally resolve to the closest endpoint that belongs to that particular SaaS application. That's the first thing. The second thing, I mentioned we are going to send this DNS request over the best performing path. So what that would mean is the DNS request is optimized. It is going over the best performing path at that point of time. And then it is also using the same server that was used earlier to know the probe endpoint, probe IP address, so that we are probing the same information. And then we are also using the same DNS server to resolve the application traffic. So that consistently makes sure we are ensured and ensures for us that we are using the same DNS server throughout the user traffic flow. And now when the router gets the response back from the DNS server, obviously it's going to rewrite the DNS request and then send it back to the client. I think there's a question. Oh, sorry, 1 second.
Why aren't you using nbar? Why you are not using nbar?
Got it. The question was, why are we not using nbar for this? So the answer to the question is, we are indeed using the nbar in order to identify the DNS requests, and then we are redirecting the DNS request over the best performing path. So the nbar is what is used for the classification. Now what I was talking about is the DNS traffic packet being redirected to the via the best performing path, which is the path selection that Cloud On-Ramp for SaaS is doing. Does that answer your question? Okay. I mean, if not, I'm happy to have a conversation after the session as well. Will be further to clarify that. Okay.
What if the client laptop is running some sort of proxy services? Then the moment packet arrives as the SD-WAN, you will be coming up with different classification already in terms of application criteria matching. And if you are running some data policy, right, to the SaaS destination, classification towards the DNS will no longer work.
Correct. Okay. The question was, how does it work when we have proxy in place or when the client laptop is using proxy in order to access the SaaS application? So yeah, if we are having proxy in place, the classification would not work because all the traffic that client is accessing is now just being destined to one single IP address that is a proxy server IP, and we won't be able to essentially classify it. So the prerequisite in order to use the cloud on-ramp for SaaS is to bypass proxy for those trusted SaaS applications. So the proxy should not be used for the SaaS applications for which you are looking to do the optimization or configure cloud on-ramp for SaaS feature. Hope that answers your question. Okay. So now moving to the second step that we have was the quality probing, which is where we are now measuring the performance across all the ISP circuits that we have. Right? So there could be different scenarios like dual DIA, where you have two direct internet access circuits available on the branch location. Or there could be a branch location where you have a direct internet access path, and in combination, you have an MPLS or a private link to a data center and egress from there. So if it's a dual DIS scenario, we would directly send probes via the ISP1 or ISP2, in this case that I'm showing on the picture, to the endpoint of the application and then measure the loss and latency. And if it's in a single DIS scenario, for the direct internet access circuit, the behavior is still the same. And now for the path over the tunnels or over the MPLS circuit towards the data center, we would do a composite path calculation, where essentially for this tunnel that is between the branch to the gateway site, we would use our BFD probes that are already running as part of the SD-WAN tunnel and measure the loss and latency. And from the gateway towards the internet, we would again use the HTTP ping results. And that composite calculation is done and compared to see which path is the best one to use. Should we go via DIA, or should we backhaul the traffic towards the gateway and egress from there? And all of these are just going to happen behind the scenes transparently to the users. So all we would have to do is enable cloud on-ramp for SaaS, and from there on, router will start taking over and select the best path at any given point of time for the SaaS application. So now, how do we do the quality probing, right? This is more as an information slide to see how frequently we probe, because I said so far that we are sending HTTP pings to measure the performance, to measure the loss, latency on the particular paths, right? Here is the frequency where we essentially start with sending one HTTP or HTTPS ping packet per second for the first 10 seconds, and then we sleep for another 20 seconds. And then it goes up to aggregate over a 12-minute rolling interval. The moment I show this slide, the very first thing that comes top of to any customer or any user mind is, can we tweak this, or can we have more customization, right? Yes, we do offer this not directly by modifying those timer values, but this is from 2013 or 1713 release. So if you're using a 2015 long-lived release, you get this benefit where you can associate the tracker status to the cloud on-ramp for SaaS path selection. And now within tracker, you could configure your multipliers and how frequently you probe and control that, and then bring down to failover duration to less than a minute or to a minute, depending on how aggressively you can configure that tracker. And it's an additional knob that you would enable it. And let's say if you are using config group or policy group, it's even more simplified where this option is enabled by default. So you don't have to worry about it. And if you just have tracker configured, we start using it in order to make sure we fail over fast and converge faster based on the requirements or based on the tracker settings that have been set on the particular branch location. All right. So the final step, as we saw earlier in the slide, is calculating the score and selecting the best path, right? So based on the loss and based on the latency, we calculate an individual score for each metric, like a loss score and the latency score, and then we average that out in order to measure overall quality of experience score and select the best path. So in the examples that I'm showing here, in the first example of dual DIA, on the ISP1 is having the best score of 10, and the ISP2 is having a score of 8. So now essentially we are selecting the path of ISP1 for the Office 365 application. And similarly in the single DIA as well, the best, again, like I said, we do the composite score calculation for the DIA path and also for the gateway path by considering the tunnel performance into account. And those things considered together, in this example, we have 9 over the local breakout and a score of 4 over the gateway. So essentially, we are preferring the local gateway or local exit at that point of time when the scores are like this, as we show in the example. So now let's look at how do we configure this. So essentially, in order to configure this, there are 2 options. One is you could use our guided workflow that we have introduced from 2015-17-15, which is our last year August release that we have made available for the use. And essentially, when you go to the cloud on-ramp for SaaS, we will also later look at as part of the demo as well. There will be a button on very top which says Enable Cloud On-Ramp for SaaS. Once you click that, now it will guide us through different steps that you could take in order to enable Cloud On-Ramp for SaaS for certain applications. That's one approach of doing it. The second option is, again, this is very optional step where if you don't choose to use the guided workflow for whatever reason, you could directly go ahead and configure it in the policy groups. So the constructs that we are using in order to configure or enable Cloud On-Ramp for SaaS is basically the policy group construct that we have as part of our configuration. And within the policy group, there is an application priority and SLA policy profile that you would have configured in order to manage your application-aware routing policies or QoS and so on. It's the same policy profile that is used for this as well. So the first option that we're seeing here is a simple layout option. And now within the simple layout option, what you're essentially going to look at is this internet offload traffic section that we are having, where you have 2 options, where you could either be selecting a direct internet access circuit, or you could be selecting SSE offload traffic option for the SaaS traffic at that particular branch location. Now, depending on which application list that you select, let's say on direct internet access or a secure internet gateway, it is going to probe the corresponding paths. What I mean by that is, for example, if an application list is configured in a DIA, we are going to probe the direct internet access circuits in order to measure the performance. Or on a branch, let's say if we have applications which needs to be probed over SSE tunnels, we do support that as well. So essentially, if there is a tunnel going from branch location to Cisco Secure Access or Zscaler, we can send probes through those tunnels and then measure the performance and then select the best tunnel out of that and egress from there, from that particular SIG provider data center location. So all of that configuration would be automatically handled by the simple layout workflow. So essentially, in the simple layout, all you'd be doing is selecting the application and select which type of exit that you're going to do. Either you're going to do it with SIG or you're going to do it with a direct internet access. And that will automatically add the required policy sequences. And the other option that we have for configuring the application priority and SLA policy is using a more advanced layout. This is typically used in scenarios where you would like to configure sequence by sequence within the policy and take complete control of handling your policy sequences. And that's when there are more detailed steps that I've put in the slides. Again, this is not going to be required typically in your operations or day-to-day network, because the very first scenarios of almost 99% in the deployments, they would be going with a guided workflow. If not, you would probably then go with simple layout. In a very rare scenario is when you would start going to the advanced layout and add these individual sequences that I'm going to talk about now in this section. So essentially what you need to do is manually first create a particular sequence that I'm showing in the first screenshot on the top, where select the application list like Office, Salesforce, or Box for which you need the Cloud On-Ramp for SaaS to be enabled. And also select RFC 1918 address ranges so that essentially we have seen this happening in certain scenarios, especially with Microsoft, where you have an on-prem Exchange server or on-prem SharePoint that could be running from the legacy deployments. It could be running on RFC 1918 addresses, and we should ideally not be selecting them and not doing SaaS optimization on it, because your on-prem services won't be available over the direct internet access or internet paths, right? So that's the reason why we would add this additional sequence to match any destinations that could be going to RFC 1918 or your private address range, and then bypass cloud on-ramp for SaaS on top of it. Again, if you do this through the workflow or the simple layout, SD-WAN Manager does all of this automation backend and adds the necessary sequences, and you don't have to worry about adding these sequences manually. And the last step is, once you have all the sequences, you would select the cloud on-ramp for SaaS as an action in the policy sequence, and then select the counter action, and then save the policy and deploy the policy group as a final step. Now, deploying the policy group is a common step, so no matter which option that we use, whether a guided workflow or whether you use a simple layout or advanced layout, whichever option that you use, the final option of deploying the policy group is something common that we have to take in any of those scenarios. And what we do as part of the deployment is, this is a time where it says, is it a DIA site, or is it a gateway, or is it a data center site that we are looking at deploying this configuration on. And then there are certain additional options that you can also enable, like load balancing across the equal performing paths. Or you could also select probing a specific DIA TLOC or probing a specific SIG tunnel as part of those options when you're deploying it on a particular branch location. So that's what we do during the deployment phase. OK, that said, now let's look at a quick demo. I'll show how the guided workflow would look and everything as part of the live demo. So this is, again, running 2015 or higher release. So this is introduced, as I said earlier, starting from our 2015, 17, release code. So we would navigate from configuration to cloud on-ramp for SaaS. Now, once you're here, you would see the list of SaaS applications for which, maybe I'll also zoom in a little bit. You would see the list of all SaaS applications for which the cloud on-ramp for SaaS is being enabled and running. Like once it is enabled, we essentially do the same thing, like probing, start measuring the performance, start taking over the traffic classification, and then send the traffic over the best performing path, right? So it is all of those actions are being done for these various SaaS applications in place. Now, to enable it for new applications, we're going to start off with clicking Enable Cloud on-ramp for SaaS. And now this shows us a list of standard 14 applications that we support by default as part of Cloud on-ramp for SaaS. As an example, let's say now we want to optimize traffic for Box application, right? So you're going to select Box as an application from this list, and then go next. Now here is where you would already see the configured or existing policy groups that you're using as part of your network, which is what you would have configured in order to manage your application-aware routing policies or QoS policies that are part of your SD-WAN fabric already, right? So you're going to select the same policy group here, and click Next. This is where you could just see summary of actions that we took, where previously it was enabled for Office, this specific policy group. And then for Box is now what we are adding. And this is a policy group that we are touching in order to make this configuration. And click Submit. Once we do this, behind the scenes, the workflow is automatically adding all the required sequences that are needed in order to enable Cloud on-ramp for SaaS for Box application. So those are simple steps that you would use as part of the guided workflow to first set up Cloud on-ramp for SaaS, and now do the final step of deploying this policy change. So now when you go deploy, it will now again show you a list of all sites that are associated to this policy group. You would select those sites on which you would like to apply this policy group on, and go to the next stage, where you would now see those deployment options that I was talking about earlier, to say whether is it a gateway site or DIA site, or what type of site that we are looking at, basically. So let's say select San Jose as a site example again. Now you'd see all those options that I talked about. And now let's say if this is a DIA site, for example, you'd select DIA, and the type of probing that we want to do. TLOC is basically the direct internet access circuit option, is what it refers to. And the other option is secure internet gateway option, which is probing over SIG tunnels that are going to your SIG provider. So you would select either of those options. And the additional flexibility is, so as we talked earlier about path selection, what is the default behavior of cloud on-ramp for SaaS is select the best possible path and steer the traffic all through that best performing path. But in a typical network, there could be scenarios where you have two DIS circuits, and both of them could be equally performing good, right? Why don't we take advantage of such kind of scenarios and load balance traffic now among those equally performing best paths? That's where you would enable load balancing option, and then you can now also configure, let's say, what is the loss and latency variance that you want to allow. Like, for example, use that alternate best path only if it is in 2% loss or 50 millisecond latency variance from the best performing path. And now for load balancing, we also have this option called source IP-based load balancing. The significance of this option is this will ensure a particular user traffic is always sticking to one internet circuit. And that will ensure the SaaS application sees the particular user traffic coming from single public IP address of that internet circuit, and it doesn't switch over between multiple circuits and doesn't cause any session reset activities that could have happened for the user. So that would be the significance of using this additional option like source IP-based load balancing option. There's a question.
The question is, this works for IPv4, as I probably have a NAT somewhere. But if I have an IPv6 somewhere, I will be directly, let's say, going with my IP address into the internet then, and probably all networks are routed to, let's say, both DIA things. Is there any problem?
Got it. So the question was, how does this work in case of an IPv6 deployment? So currently, Cloud On-Ramp for SaaS is supported only for IPv4 networks. So we are talking here only about IPv4 NAT translations and IPv4 network scenarios. It doesn't work for IPv6 traffic yet. And once we start developing it, that's when we would definitely start considering scenarios like you mentioned. How does NAT work in that? Because in those cases, NAT is not even relevant in case of IPv6 networks, right? So that's something that we have to consider when we start developing or prioritizing Cloud On-Ramp for SaaS for IPv6 deployments. Okay. Now, finally, we're going to do next and deploy the policy. And this is where essentially there are two things happening. One is it is pushing policies to the SD-WAN controller, or what was formerly known as vSMAT. And then it is also pushing the configuration to the SD-WAN edge routers in order to start probing and start measuring the performance, and then start selecting the best path for the SaaS applications. So this is how simple you could configure Cloud On-Ramp for SaaS. I'll go back to the slides. Now we look at Microsoft 365. What are some of the enhancements or that we have done specifically for Microsoft 365? Before we get there, I wanted to quickly touch on what are the common challenges when it gets to the Microsoft 365, in addition to the SaaS optimization challenges, right? One is Microsoft has different type of suite of applications. It's not one type of application. Like, to explain in simple terms, if you're talking about Box, all we are looking at is more like a storage files or transactional file traffic, right? But whereas when you talk about Microsoft 365 as a whole, it has various set of applications within that, like Teams, which is more of voice video traffic. It has SharePoint, which is more of a transactional type of traffic, right? The way you would optimize for them could be different. I mean, the way we select a best path for Teams should not be the same way how you select a best path for the SharePoint. So all of those things are what considered in addition to the Microsoft 365 on top of the basic Cloud On-Ramp for SaaS. And then we offer some of the benefits, such as dynamic URL categorization when it comes to Microsoft 365. So before I get into the benefits or concept of dynamic URL categorization, Microsoft 365, on their end, they classify different endpoints into different categories, like based on the latency sensitivity of the application endpoint type. And then they periodically keep that information up to date when they add new endpoints or when certain things change in their infrastructure and so on. And we use behind the scenes SDAVC and NBAR together in order to get that classification information regularly, like every 24 hours, and get the updates and install it as part of our NBAR application cache and recognize the Office 365 traffic from the very first packet. Not only that, it helps us to know a specific endpoint belongs to this particular category. And now in the cloud on-ramp for SaaS configuration workflow for Microsoft 365, there are options where you can select do the cloud on-ramp for SaaS only for an optimized category or only for allow category, which is their way of categorizing different endpoints. So there are options now to enable cloud on-ramp for SaaS at that granular level and select or use the resources of the best performing path for only certain type of endpoints. Another use case is, for example, if you want to do an optimization for only Teams traffic and not do SharePoint. Or it could be also a security compliance scenario where only Teams traffic is allowed to go over the internet traffic, but whereas the SharePoint or Exchange should go over a data center and go through the central firewall inspection and egress from there. So this option also offers that flexibility where you could enable cloud on-ramp for SaaS for specific type of application service areas, like just Teams or SharePoint or Exchange, and do direct internet breakout only for that specific application type within the Office 365 suite of applications. The next integration that we've built with Microsoft 365 is the telemetry integration, where we are getting the application score from Microsoft, which is an indication of Microsoft view on their application path on the performance of the application when it is going over the particular path. And then we consider that for the path selection and do the best path selection for Microsoft 365 traffic based on that. We'll look at those things in more detail as we go into subsequent slides. Again, these are more some of the information slides that I wanted to point out because within Cloud On-Ramp for SaaS, we see a lot of questions around application classification, how we handle first packet match, or how do we classify, how do we ensure traffic classification is always done the right way for the SaaS application. This is an infrastructure that we use behind the scenes, which is nothing but SDAVC in the back end, which is powered by application catalog as a front end where you interface with the SDAVC to know what are all the protocols that are supported or applications that are supported for classification and different SaaS feeds that we get. So like for 28 SaaS applications, we periodically get their IP address information, domain information, and we use that to enhance our application classification. And you can look at all of those SaaS feeds information as well as part of the application catalog UI section where you could see which IP addresses are being classified as Microsoft services or which IP addresses are being classified as WebEx and so on. Again, these are some more slides to just see what are the prefixes that are being classified as Microsoft or what are prefixes that are classified for WebEx and so on. Again, this is a list that you don't have to worry about unless you're troubleshooting some classification issues. Because I saw in the very early beginning of the poll that there are certain concerns about DPI not classifying the applications properly, right? When you're trying to troubleshoot certain things, you would come to these SaaS feeds and then look at a specific destination IP. Is that something that we are receiving in this feed? If so, what is the application name that it is being mapped to? And are there any differences or discrepancies in that? And that's when you essentially start looking at these kind of information and debug from there on. But otherwise, these are all just going to work seamlessly in the backend once the SDAVC is enabled. It will start getting the cloud feeds, push it to the NBAR agent that is running on the SD-WAN edge router, and the router will start consuming this information in order to do the traffic classification and then send the traffic on the best path that it is computing. Okay. No, the question is about licensing. Is there any additional license required? No, this is all part of our DNA Advantage and DNA Essential licenses. So depending on which license you're using, whether you're going to get the custom app support or not, so there are certain differences. But otherwise, it's all part of the DNA licensing that is used for SD-WAN.
Including SDAVC?
Yes, yes, including SDAVC. Yeah. There was one more question. Sorry. Yeah, no worries. Go ahead. Sure. The question was, how is Microsoft Inform Network different from our standard HTTP pings? If you could hold on for just a minute, I'm going to cover that in more detail in upcoming slide and show what is the value prop of this scenario.
Yeah, the question is, if I classify applications somewhere else, for example, in my SDAccess fabric, is it possible to preserve or exchange this classification patterns with the SD-WAN
Got it.
devices.
So the question was, if the applications are being classified somewhere else, let's say in the SD access or so on, can we get that classification information or share that classification information with the SD-WAN and leverage that? The answer is no. I mean, today there is no support to share such classification, but I think that's definitely a good point. We start looking at how we can integrate more with Catalyst Center and SD-WAN Manager and see how we can preserve that and offer more seamless way of classifying the traffic. And before I get into the details about the informed network routing, just one more reference slide. We also have introduced a cloud-sourced application, which is now different from the SaaS feeds. SaaS feeds were more about just getting the IP address information or domains that belongs to some of those 28 SaaS applications that we looked at. But with cloud-sourced applications, we are getting various websites information as well, using, again, SDAVC Cloud in the backend. This would now give us option to classify much beyond 1,500 plus applications that are by default allowed or supported as part of the NBAR. So 1,500 standard applications that are part of NBAR, and this is again 2,500 plus. In addition to that is what we'll now be able to classify. And once we start classifying it, the benefit for Cloud On-Ramp for SaaS is now we can optimize all those applications as well using Cloud On-Ramp for SaaS. Okay. So now I'll touch upon what is a benefit that we get with the Microsoft Informed Network Routing. Right? When we are doing typical network probing, which is nothing but the WAN monitoring probes that we talked about, where we are essentially probing from the branch location to the Microsoft endpoint or the Microsoft data center and selecting the best path. But what is missing in that scenario is a client status, which is on your LAN side, or it could be something like a service status, which is within the Microsoft data center, right? That information is not something that WAN monitoring probes can capture. And the other use case is WAN monitoring probes, like I mentioned earlier, are HTTP ping packets, which is not necessarily going to get the same treatment like how the application traffic could be. Like to give an example, a link could be capacity restricted at a certain capacity, and now when you start downloading SharePoint files, it might start overwhelming the link capacity, and SharePoint traffic might see the traffic drops or packet drops, whereas HTTP pings, which are smaller ping packets, they will not be susceptible for such kind of capacity restrictions, right? So those are the two scenarios where we now get the end-to-end visibility, and how we get that is now Microsoft is monitoring the traffic. When you enable this feature, essentially what Microsoft does is it monitors the traffic that is coming from the user, going all the way up to their servers, which are within their location, and then tells us what is their opinion of the current path that it is taking. And now we consider that and then steer the traffic to the alternate path, hoping to that improve the performance of the application. Again, the WAN monitoring probes is still going to have the higher preference first. So if you have two equal performing paths where WAN monitoring probes are already saying they are performing equally good, but whereas on the path one, if the Microsoft says it is not doing good, that's when we would switch to the alternate path, and that would give us more better performance because on the alternate path, there could be no such capacity restrictions, and the SharePoint traffic would now be not susceptible to such kind of rate limiters or capacity restrictions that are in place on that alternate path. Okay. We could also look at some of the information as well here. This is an analytics dashboard that you would see when you start enabling path analytics or Microsoft Informed Network Routing. And what you notice here is there is a small path change that we notice here, whereas for a particular brief point of time, it was using the bottom circuit. When we started using that particular circuit, we started immediately getting an opinion score from Microsoft, which is the last graph that you see here, saying that it is either degraded or bad at that point of time throughout on that particular circuit. We consider that feedback, and then you see an immediate switch at 8 o'clock in the morning to the other alternate circuit, gig 1. And once it started going on the gig 1, now it started initially probably during the failover time, it was still not calculating appropriately, so you see it's pretty bad, but then now it started restored, and then it is having a good experience for the office on the alternate path. There's a question. Yeah. So the question was, does this all work in the scenario where both the circuits are connected over one particular router? Yes, the answer is correct. So we are looking at scenario where we have two circuits available for a particular router, and we are using the application feedback in order to select the best path out of it. Okay. Okay, good. Again, this is one more information slide, more to do with the traffic steering option. So in case if you're not looking to use the Microsoft telemetry for our traffic steering, that is also supported. You could use this feature just to get the visibility, just to understand what is a Microsoft opinion on these paths. And then later at point of time, if you'd like to start using the telemetry scores in order to make the path selection, that is also possible. So doing path selection based on this telemetry is not a mandatory option. There's a flexibility where you could choose to just do the legacy way of doing cloud on-ramp for SaaS select path based on the path probing, and then see the traffic based on the HTTP ping results that we have. Okay, let me go to quickly demo. So in order to do this, essentially we are using analytics as well in the backend, because we are now looking at sharing the whole telemetry data between Cisco and Microsoft, and then start using that for path selection and so on, right? That's essentially why we would use this analytics as well. And now for Office 365, in this case, when we go and select a particular site where I have the telemetry enabled on, you'll start seeing the Path Analytics tab, where it will show us over the period of time what are the paths that are being used, and what is the bottom one that I said is a Microsoft opinion score. That is what we are getting from the Microsoft. And then we are using that in order to compute an SD-WAN computer score, which is considering both WAN probes and also the Microsoft telemetry scores. Along with that, what I also wanted to show as part of the demo was, earlier I said, it gives us that end-to-end visibility, right? So now the Microsoft telemetry, which in that there is a latency value as well that is provided to us, which tells us end-to-end from the user all the way up to the servers that they are accessing, what is the latency, which is again measured by sampling the actual user traffic and telling us these user traffic on this particular location is seeing around 200 milliseconds and so on. But whereas if you see the network probes, this is the network telemetry that we are having, is having just around 3 milliseconds latency. What this means is either the application traffic is being treated differently on these paths at that point of time where the latency is spiking up, or there could be a problem on the LAN side of the network where the traffic is having some access point issues, or it is being delayed on somewhere within the LAN network. At least you could pinpoint to that based on the information that you see here. Okay, let me go to the. I'll quickly touch upon Cloud On-Ramp for SaaS, and then we get into SIG and some of the deployment scenarios as well in the rest of the 10 minutes time that we have. With respect to WebEx, we again do the same kind of best path selection and everything, but the key difference when it comes to WebEx is we are probing per region. So we have much more granular information, like in terms of what is the best path to go to WebEx traffic, which is corresponding to WebEx US West or EU Central, and so on. So it is going to be done per region, and then we do the best path selection for each of those WebEx region traffic. And this is the information, like I said, when you go to the WebEx, once you enable it, you start seeing for all the regions that we support, like there are 10 regions that we support today. So for all of those regions, what is the best performing path, which paths are being selected for those different type of WebEx traffic going from the branch location. Within WebEx as well, we have integration with the telemetry, so where we start, like similar to Microsoft, how we see the network telemetry and application telemetry. The same way we start seeing all the network telemetry information as well, like network probe information and so on. And then also show the application telemetry that is shared by the WebEx control hub for us, and then show what are the frame rate, media rate, some of the WebEx call stats, essentially indicating how the performance of the WebEx traffic is on these branch locations. So some of the examples here is like you see the resolution height and so on, like gets dropped when the loss and so on is increasing, right? So you get to see what are the metrics that corresponds to different calls that are happening or different meetings that are basically happening in that particular SD-WAN branch location. So Cloud On-Ramp for custom applications. All the benefits that we talked about so far for like Microsoft or WebEx can also be some extent brought to your custom application that could be running within your data center location or as part of your cloud-hosted infrastructure. How we do that is you could define custom applications, and then you could define the probe endpoint that we can use in order to start sending HTTP ping or HTTPS ping in order to measure the performance across all the available paths, and then start selecting the best path in the same way we would do for either standard applications or for these custom applications as well. In addition to these custom applications, you could also look at leveraging those cloud-sourced applications that I talked about earlier as well, and start optimizing them using Cloud On-Ramp for SaaS. Again, there are certain restrictions when it comes to using it with the current UX Roto workflow. We have a feature in pipeline coming in for the end of this year, and that will address all of it if you're using configuration group or policy groups. But if you use old way of defining with templates or policies, these are already supported. So just wanted to quickly call that out, that restriction as well. Now we look at how does this work in a security deployment, right? In case of security deployments, what essentially we are looking at is from the ISP1, we are sending the traffic over the SIG tunnels to either, let's say, Cisco Secure Access, Zscaler, or Netscope, or Palo Alto, and so on, and from there, accessing the SaaS application. So in that kind of deployment scenarios, what we do is send the HTTP pings, again, through these same IPsec or GRE tunnels that you would have established to the SIG provider, and from there, egress to the SaaS endpoint that we are probing, and use that in conjunction with alternate path performance metrics that we have, and then select the best path. So scenarios could be you have 2 tunnels going to SIG data center. We could help select the best path, best tunnel out of them. Or we could also help select the SIG tunnel versus backhauling the traffic over a data center and egress from there as well. So those are the kind of scenarios that we could do with the Cloud On-Ramp for SaaS integration with security in place. So now we look at some of the deployment scenarios. Again, these are put more as a reference slide. There is one deployment scenario specifically which I wanted to touch upon. But in the most scenarios, it is the same kind of probing mechanism that we talked about so far. Like the first scenario that we talked about was dual DIS scenario, where you have a router, a single router with 2 ISP links. We could probe on both of them and select the best performing path. That's one kind of deployment scenario, right? The second one is where you have the local internet exit, or in combination with that, we have an MPLS link to a data center and egress from there using a transport VPN circuit. That's one kind of deployment where essentially once the traffic hits on the data center, it egresses using the VPN 0 exit path and then go to the SaaS application. I think there was a question. Mm-hmm. So the question was, for all of this optimization that we talk, does it take into account for the existing flows or does it take into account for the new flows? The answer to your question is yes, it is always going to take into account only for the new flows that are being classified as an application. So if there's any existing session that has been already running, either before the feature was enabled or so on, those things won't be reset after we enable Cloud On-Ramp for SaaS. Yeah. So other combination in case of gateway deployment that we have seen is nothing changes on the local internet exit on the branch side, but on the gateway, once the traffic hits on the gateway side, now instead of sending the traffic over the VPN 0, you could be sending this traffic over a service VPN interface to a firewall and inspect on that particular firewall and egress to the internet from that particular firewall. So that deployment option is also supported as part of Cloud On-Ramp for SaaS. So on the gateway sides, no matter whether the internet exit is on the VPN 0 or on via service VPN towards the internet, towards the firewall and to the internet, both the deployment scenarios are supported with Cloud On-Ramp for SaaS. And this is another scenario of where we use SIG in combination with the data center, like where essentially you're probing the SIG tunnels from a particular branch. And in combination, you are looking at the performance over a data center router, and then from the data center, you could have firewall in place, like we just discussed in the previous use case, monitor the performance via those paths, and then select which path is performing the best. Okay, now this is a deployment scenario that I wanted to focus more upon because this is what that we recently saw also in one of the deployment, where how does this work in combination with the umbrella DNS security policies that you can configure on the Catalyst SD-WAN routers. So when you have umbrella DNS security policy in place, now essentially all the DNS traffic is now being subjected to this security policy enforcement where we are encrypting the DNS request and then adding the eDNS context, and then sending it to the umbrella to resolve. And on the umbrella, there could be policies defined in order to whether to allow certain kind of DNS requests for applications or deny them and so on as well, right? Now, what happens when we have that policy defined, and now let's say the cloud on-ramp for SaaS, there are two possibilities in this kind of deployment where the ISP1 on the branch side is the one that is performing the best. So now the DNS request is encrypted by the umbrella DNS security policy, added with the eDNS context, and then sent over the best DIA path that cloud on-ramp for SaaS has selected. And nothing changes from the DNS policy enforcement on the umbrella side. They would just look at the policy, allow, deny the DNS request. We get a response, and then we forward it to the client afterwards. But let's say at some point of time, if the ISP1 circuit starts degraded, like where the performance on the ISP1 circuit is now going down, so cloud on-ramp for SaaS will detect that path degradation and then changes the best path now to go over the MPLS towards the data center exits. Now, what's happening now within that scenario is the branch router will still send the DNS request with the eDNS context added. It is now sent to the gateway side. And on the gateway side, we need something called as umbrella virtual appliance on the LAN side in order to have this DNS security policy working end-to-end from the intent standpoint of view. Again, from the intent standpoint of view, if we are not worried about having the DNS security policy enforcement done when the traffic is going over the gateway, you could leave that out, and then the traffic would just be handled in the same way how Cloud on-ramp for SaaS would have handled it when it gets from a remote branch location. Basically, the eDNS context will not be used, and it will just send it to the DNS server that is configured on the gateway and resolve it on. But in case of where you want to maintain this consistent intent, where you want to use the umbrella DNS server and do the security policy enforcement, no matter what is the best performing path, that is when exactly you could use an umbrella virtual appliance, which could be running on the LAN side, which will receive these DNS requests, and then encrypts it and sends it to the umbrella DNS server, where essentially you do the same kind of policy enforcement. So now this will essentially guarantee that no matter where the traffic is going across, Cloud on-ramp for SaaS will help select the best path based on the performance, and the umbrella DNS servers are being used to enforce the security policy intent. And on the umbrella side, the policies could be also defined based on the user group AD, and for a specific user, you could allow certain type of DNS request, and all of those security policies could be implemented on the umbrella side. So that's how these two can interop together in order to achieve the scenario. Question?
Then this may not be a relevant use case if you're using certain other product as a SaaS SIG service, for example, Palo Alto, which is also doing a DNS security, right? As you talked about, in Umbrella, you have a mechanism for that, but may not be with the other vendor product.
Right. The question was, can we extend this kind of deployments to like other vendors who could also be supporting similar kind of DNS security policy, let's say Palo Alto and so on? Yeah, again, we don't know the answer to it because we have tested and validated this today only with the umbrella DNS server. But depending on what capabilities we have on the other vendors, we could definitely also look up if that's of interest on any of your deployments or your customers. Let us know. We could look at, see what we could do, because essentially what we are leveraging here is just some of the inbuilt behavior of the Cloud on-ramp for SaaS, and then using DNS security policy on top of it, but it just needs some kind of validation before we claim support for that scenarios. Thank you. Okay, thank you. We'll quickly try to summarize all the topics that we've discussed so far. So very initial thing that we started off in the today's session was looking at what are the components of Cloud on-ramp for SaaS in terms of how do we resolve the DNS request, how do we probe over the path, and how do we select the best performing path, and so on. Then we looked at some of the specific integrations that we have with the Microsoft. Then we briefly touched upon the differences that we have with the WebEx integration, like where we probe per region and then get the information about traffic going to different WebEx regions across the world in a more granular way. And looked at quickly in terms of what are the telemetry information that we get also as part of the WebEx integration. And then we looked at how do we use custom applications and define Cloud on-ramp for SaaS for custom apps. And then we looked at scenarios of combining security or SIG or SSE together with the Cloud on-ramp for SaaS, how things operate together. And finally, some of the deployment scenarios, right? That was a really quick summary. Now, these are some of the resources that you could use to learn. So we have a YouTube channel where we weekly post some of the new content. So feel free to subscribe to this to get more up-to-date information about the latest enhancements that we are introducing from the product side. And these are some of the demo videos that you could look at and some of the read information like to more and understand more what is cloud on-ramp for SaaS and start using it as part of your SD-WAN fabric. And these are some of the other sessions that are happening throughout the Cisco Live from our business unit. So feel free to check them out, like depending on the interest and area, what topics that you'd like to learn more. You could, in the rest of the remaining 3 days of the event, you could cover and see how much you could attend on other sessions as well. That being said, like there's a WebEx space that will still be left active. Quickly keep this. There's a WebEx space will still be kept active, like I said in the very beginning of the session. And you can feel free to post all your questions. I'll be taking a look at them and definitely going to answer them as soon as possible as well. Finally, I hope you liked the session. So if so, please do rate me. Please do fill in the session surveys. It also helps me improve as a speaker, also helps me improve the content for the next sessions and bring these kind of content back to you again in the next Cisco Live event. And there's also a t-shirt that you could win when you start filling more than 4 surveys, right? And these are some of the continuing education information. This is my email address, which you could use to contact me at any point of time if you have questions about cloud on-ramp for SaaS. I also cover other areas like analytics and so on. So I'll be more than happy to help answer your questions as well. And thank you. Thank you so much. I know it took extra 1 minute, but thank you.